Students, welcome to the Science 1 class. In this video, we are going to learn about extractive metallurgy. Extractive metallurgy is knowing about the techniques involved in the extraction of metal from its ore. In this table, few examples are given for more reactive metals, medium reactive metals, and less reactive metals. If a metal is more reactive metal, then the metal is extracted from its metal oxide using electrolytic reduction process by passing current. If a metal is a medium reactive metal, then chemical reduction process is used to extract metal from its metal oxide. If a metal is a less reactive metal, then by normal heating, that is by thermal decomposition, the metal can be extracted from its metal oxide. We will learn one example for each. Extractive metallurgy of aluminium is based on electrolytic reduction. Extractive metallurgy of copper is based on chemical reduction. And extractive metallurgy of iron is based on thermal decomposition. Now, we are going to learn about the extractive metallurgy of aluminium based on the electrolytic reduction. From the earth crust, we will be getting 8.1% of aluminium. We will be getting aluminium from the earth in different forms. In that minerals, if the aluminium is present in large percentage, then that is said to be the ores of aluminium. In bauxite, cryolite and corundum, aluminium is present in large percentage, and bauxite is called as the chief ore of aluminium. Let's learn about the extraction of aluminium from bauxite, and it involves two steps. Step 1 is conversion of bauxite into alumina using Bayer's process. First, the bauxite ore is crushed into powder form and taken in a container. To the powdered bauxite ore, concentrated caustic soda, that is NaOH solution, is added, and the container is heated by maintaining 150 degree temperature and 35 to 36 bar pressure. So the product called sodium metaaluminate will be obtained. This sodium metaaluminate is transferred into another container and mixed with water. On mixing with water, aluminium hydroxide AlOH thrice precipitate will be formed. This aluminium hydroxide precipitate, when heated at 1000 degrees Celsius, water content will be removed and alumina Al2O3 will be obtained. Step 2 is electrolytic reduction of alumina by Hall's process. For this process, an iron tank is used, in which the inner lining of the tank is made of graphite, that is carbon. This container is connected to the negative terminal of 5 to 6 volt battery. Now, the tank will carry negative charge, and this iron tank linked with graphite will act as cathode. inside the tank an electrolytic solution is taken, and the electrolyte contains pure alumina, which is obtained in the step 1, then molten cryolite and fluorspar. The reason of adding fluorspar is to lower the fusion temperature of aluminium. Carbon rods are dipped into the electrolyte solution. Here, all the carbon rods are connected to a bus bar, which is further connected to the positive terminal of the battery, which will act as anode. So, anode is a bunch of graphite rods suspended in molten electrolyte. Here, the maintained temperature is 900 to 950 degree. By passing current and maintaining the temperature, the alumina present in the electrolytic solution will get separated as aluminium and oxygen. Aluminium will move towards the iron tank and gets deposited in the iron tank as we are maintaining 900 to 950 degree temperature. The deposited aluminium will melt and flow out through a wall as molten aluminium. Oxygen will move towards the anode. As anode is made of carbon, oxygen combines with carbon to form carbon dioxide gas and gets liberated. Now we have separated aluminium from alumina using Hall's process. Let's learn about the physical properties of aluminium. It's a silvery white metal. It has low density, that is, it's a lightweight metal. That's why it is used in making aeroplane parts. It is malleable, that is, can be made into thin sheet, and ductile, can be made into thin wire. It is a good conductor of heat and electricity. As it is a good conductor, utensils and electrical posts are made of aluminium. Its melting point is 660 degree. It can be polished to produce a shiny, attractive appearance. That is, it is highly lustrous. Next, let's learn about the chemical properties of aluminium. Reaction with air. Aluminium will not react with dry air. But at 800 degree, aluminium oxide will be formed. Aluminium Al plus air O2 will give Al2O3. Let's see how we got Al2O3. The valency of aluminium is 3 and oxygen is 2. When you cross multiply these two valencies, you will be getting Al2O3, aluminium oxide. Next, when aluminium is heated with nitrogen gas, we will be getting aluminium nitride. Aluminium Al plus nitrogen N2 will give Al(N). The valency of aluminium is 3 and the valency of nitrogen is also 3. When you cross multiply, you will be getting Al3N3. By taking simple ratio, you will be getting 1:1. That's why it is given as Al(N). Second chemical property is reaction with water. Aluminium will not react with water because an oxide layer will be created above aluminium and water will not be able to reach the aluminium. Hence, no reaction will take place. But when steam is passed over aluminium, aluminium oxide and hydrogen gas will be liberated. Third property is reaction with alkali. Alkalis or alkali metals, that is lithium, sodium, potassium, rubidium, cesium, francium, first group metals. So bases of these metals are called alkalis. Here we are taking strong caustic alkali, that is sodium hydroxide solution. On treating it with aluminium, we will be getting sodium meta-aluminate NaAlO2 and hydrogen gas will be liberated. Fourth property is reaction with acids. Aluminium, or generally when a metal reacts with acid, will liberate hydrogen gas. Here, when aluminium reacts with hydrochloric acid, HCl will give aluminium chloride, AlCl3, and the remaining hydrogen are liberated as hydrogen gas. In aluminium chloride, the valency of aluminium is 3 and the valency of chlorine is 1. So by crossover valency, we got AlCl3. Next, reaction of aluminium with sulfuric acid, H2SO4. With dilute sulfuric acid, we get aluminium sulfate, Al2SO4 thrice. Here, the charge of sulfate is 2 and the valency of aluminium is 3. When we cross multiply, we will be getting Al2SO4 thrice and hydrogen gas is liberated. When aluminium reacts with concentrated sulfuric acid, sulfur dioxide gas will be liberated from sulfuric acid. Fifth property is aluminium is used as reducing agent. Aluminium is a powerful reducing agent. Any reduction process can be done by using aluminium. For example, aluminium is taken in the powdered form and burnt with iron oxide. So, on igniting, iron alone will be obtained. It's an exothermic process. And this process is known as aluminothermic process. As we are using aluminium and heating, this process is named as aluminothermic process. Aluminium is treated with Fe2O3. Here, aluminium will react with oxygen of Fe2O3 and get oxidized to aluminium oxide, Al2O3, and iron oxide is reduced to iron. In this reaction, heat will be liberated. Hence, it is an exothermic reaction. Finally, let's learn about the uses of aluminium. It is used in making household utensils, electrical cable, and in making aeroplane parts and machinery parts. Okay students, that's all for today's class. In this video, we have learnt about extractive metallurgy of aluminium. Thank you, students. Have a good day.